Welcome back. This is Anesthesia 101online.com. I am your host, Siv. So it's the middle of the week now. We've got some sunshine finally in Massachusetts, so it's nice and warm out here finally. It's beginning of October, so we had a little bit of rain. It was been raining for the past 2 weeks. Finally got some sunshine out there. I'm actually going to go, after I film this, I'm going to go outside and enjoy this sunshine of ours. So finally, it's been a gloomy past 2 weeks, but we're back in session, so we'll start this off. So this is episode 8. We're going to talk about sodium potassium pump, and we'll keep it simple today, keep it light. I want to go out there and enjoy this nice weather of ours. So again, this is Anesthesia 101 online. I am your host, Siv. We're going to talk about sodium potassium pump. So let's jump right into it. So what's the sodium potassium pump all about? I mean, why is it important? It's important because this sits on your cell membranes. This could be your sarcomeres. This could be on your muscle cells, your myocytes. So this is very important because this is where your action potential can occur as far as your electrical conductivity, your muscle contractions in your heart, muscle contractions in your body, and then any kind of neuronal action potentials. This is where this all comes into play. So let's start it off right now. So what is a sodium potassium pump? Why is it important? It maintains the concentration gradient between sodium and potassium across the cell membrane. It's responsible for creating electromagnetic charge inside the cell, causing this gradient and therefore giving you an action potential. So as you can see in my diagram that I'm sharing here, there's 3 sodium ions out there and there's 2 potassium ions coming inside. Now, the reason I call it a pump because the potassium ions always leaking out. So the potassium actually needs to be pumped back in. In order for this whole pump to happen, you need ATP, specifically ATPase, which is the actual enzyme. So as you can see, when the sodium leaves, for every 3 sodium leaves, 2 potassium gets pumped back in. For this to happen, you need ATPase, or specifically ATPase, which cleaves off the triphosphate and makes it adenodiphosphate. So that's adenodiphosphate with the phosphate ion sitting out there. So that's how it cleaves off the extra adenosine phosphates. And then that becomes the diphosphate. So you need the extra energy to do that. As you can see, it's inside the cell and there's outside the cell. So extracellular, intracellular, cytoplasm. So, and I got this picture off Wikipedia. You can guys Google most of this stuff online. So that's what that does. So the normal resting potential for muscle cells, I want to say it's -9 millivolts. Most of the literature will go through that. There's a reading in Guyton Hall. That's the one I use, the medical physiology book that I use. It goes a little bit deeper to try and explain to you how they got 90 millivolts. Obviously, it's done in a lab, creating some kind of electroaction potential. But they were saying here that the actual numbers is from sodium you get 86 millivolts, and then the actual potential of -4 millivolts at 86 plus 4, that's you get 90 millivolts. That's how they came up with that number. But that's usually done in the lab, of course. So that's how they got that number. So think about a real quick quiz. I know we're not here to do quizzes and take exams, but eventually we'll do. This is the reason why you're probably watching this, is trying to review your stuff, get ready for exams. And by the way, if you're interested, I am actually doing a one-on-one coaching call for anybody that's in anesthesia or nurse anesthesia, or think about it. Email me again at info@anesthesia101online.com or siv@anesthesia, SIV, at anesthesia101online.com. I'm interested to do a coaching call with you guys. So if you guys are interested, email me. We'll get together on a Zoom call and go through some stuff and help you guys study. So it's going to be one of my coaching calls we're going to do together. So why is the sodium potassium pump so important? Well, think about sodium. If 3 sodiums are leaving, what do you think is going to happen? So sodium is usually attached with water, so it drags water along with it. This works well if your cells are swollen, so it it works to your effect. If a cell is swollen, it gets pumped out, so water gets pumped out, and then potassium comes back in. Now you gotta be a little bit wary because this will probably mucked up, because if somebody has some kind of cellular injury, burns, trauma, something like that. So that can affect all that. And you can think of your drugs. Lidocaine, it's I want to say it's sodium channel blocker. So you want to be careful with that. Different some of the somehow has some kind of pathophysiology diseases. So this all can get all messed up due to all that. So that's it. Keep it simple. I don't want to go too deep. I mean, if you guys want to go deeper, it's all in the literature. I'm pretty sure you got primary literatures out there that you can utilize online. There's so many out there, but I'm here to help you guide through your studies, and make sure you pass your boards, especially the nurse anesthesia boards. That's where my main focus is. All right, that's it. Episode 8 done. Down the hatch. So I'm gonna ask you guys to give me a thumbs up if you like this this video. If you have some suggestions or comments, leave the comments below. And if you're interested in that coaching call, email me at info@anesthesia101online.com or at civ@anesthesia101online.com. I also have a podcast. I don't think I've ever told you. I have a podcast. It's Anesthesia 101 Online, obviously. It's simple, super simple. And with that podcast, is not as visual, but as you can utilize it as for working out. Like me, I listen to a lot of podcasts when I'm working out. I'm driving to work, so you can use it in that manner. And it's located on Anchor, so ANCHOR FM. So you can just basically Google it. So just look for Anesthesia 101 Online Podcast, and you just show up on Anchor. That's the site I'm using to record the podcast. So be sure to check me out there. So I'm on there too also. All right. Thank you for your support. I'll see you guys next time. I'm going to stop sharing and click here and stop this recording.